Hello everyone, Dave Giles here and welcome to the next lesson of Cambridge International Education IGCSE Physics. And today we're looking at forces and friction. So today I want you to use Newton's first and second law of motion and describe friction and its effects. Now, you do not actually need to, it's not directly mentioned in the specification, knowing Newton's first and second law of motion. However, you do need to be able to apply it, so I will talk you through it. So we'll start by looking at resultant force. Now, some of this will be a recap of stuff you've done in previous lessons. So an object may have different forces acting on it, which can have different magnitudes, which means size and direction. But they can be added together to give the resultant force. This is a single force that has the same effect on the object as all the individual forces acting together. So basically, make it look like it's just one force, which is the resultant. So the force on the object is said to be balanced when the resultant force on the object is zero. Any upward force is cancelled by an equal downward force. So, for example, I've got an object on a table here. Actually, no, sorry. Let's see, it's got 10 newtons down, 10 newtons up. Any force to the left is cancelled by an equal force to the right. So we say the objects are in equilibrium when all the forces are balanced. Now, you also have to look at, so here you've got 5 newtons to the left and 5 newtons to the right, so they cancel each other out. You also need to look at turning forces for full equilibrium, but we'll look at that in a future lesson. So your weight is called the normal force. So the force on the book are balanced. So the normal force is equal to the weight, because the weight on the table, say it's 10 newtons. Then in order to stop it falling through the table, it has to have a normal force, 10 newtons in the opposite direction to the weight. So the resultant force will be zero. The book experiences no acceleration. The book remains stationary. So let's have a look at Newton's first law. It states an object stays still or keeps moving in a straight line at the same velocity unless a resultant force makes it change. So this implies a resultant force is needed to speed up, slow down, or change direction here. Now, in this one here, it looks like it's decelerating because the backward force is greater, or the frictional forces are greater than the driving force of the engine. So the plane is decelerating. What is a possible value of the engine force here? So 700 newtons of frictional forces. Now, it can't be these two because they're bigger. So that would mean it would be actually speeding up or accelerating. If it was 700 newtons, then they would cancel each other out and there would be zero resultant force. So therefore, the acceleration would be zero, would be traveling at a constant speed. So the only one that is possible is A, 0 newtons. That's Newton's first law. Now let's have a look at Newton's second law. Acceleration of an object is directly proportional to the resultant force exerted on it and inversely proportional to its mass. And from that, we get an equation. Force is mass times acceleration, or F, equals to ma, where force is measured in newtons, mass in kilograms, and acceleration is meters per second squared. We can also use a formula triangle, but I won't talk you through them. So here the car has a mass of 1,000 kilograms. Calculate the deceleration. So the resultant force is 1,500 minus 1,000, so that's 500. You've got a mass of 1,000 kilograms. So F equals ma. So therefore A is F over m, or acceleration is force divided by mass. So 500 divided by 1,000, which is 0.5 meters per second squared. Or you could say that would be deceleration, or you would say an acceleration of negative 0.5 meters per second squared. Okay, so here are some Newton's laws of motion questions. I'll let you pause it, then I will put the answers on the screen. Okay, and answers on now. Okay. So that is Newton's laws of motion covered. That's the first learning objective using the first and second law of motion. You don't look at the third law until you get to A level. So what happens when you rub your hands together? So try it yourself now, rub your hands together. And what you'll probably feel is they start to get warm because there is resistance to the rubbing. So when you rub your hands together, you feel the resistive force of friction. And that is what this lesson objective is about. Describe friction and its effects. Your hands might look smooth, but on a microscopic level, they'll have rough surfaces. I mean, even if you look at your finger now, you can see your fingerprint, which is a rough surface. So what is friction? It's a force between two surfaces that are sliding or trying to slide across each other. Friction opposes motion, so it always acts in the opposite direction to motion. So for example here, I've got a man, we'll call him Bob. He's trying to pull a box. Um, he's say pulling up a force of 1,000 newtons. If it's not moving, then that means the frictional force is also 1,000 newtons. Friction can never be higher than the force pulling, or if we just talk, yeah, friction here in this case, from a floor, it can't be higher because that would mean there would be a resultant force in that direction. Obviously, we can talk about frictional forces being higher when we talk about things like air resistance, but we'll look at that later. Frictional forces are much smaller on smooth surfaces than on rough surfaces as well. So let's have a look at some effects of friction. So it allows you to walk without slipping. So if you ever notice there's a wet floor, you're more likely to slip, or if you live in a colder country and you've seen ice, quite smooth, makes you more likely to slip. It also causes heating, which would be used for matches. If you ever lit a match, you notice the box has got a rough surface, something like sandpaper on it, and there's a chemical in the end of the match which combusts when the friction is applied to it, and that is basically how a match works. You can also get drag. So objects moving through liquid also experience resistance, known as drag. Therefore, sea creatures like sharks have a streamlined shape. So what I mean by streamline is the have a sort of pointy nose so that the water flows over them, not just hits the front of the face and slows them down too much. So air resistance is a form of friction when an object moves through air. Just as friction slows a car down, air resistance slows down a falling object by acting in the opposite direction to the motion. So here is an example of something being dropped, falling through the air. And you can see the air's hitting it here quite hard. So that will be slowing it down or stopping it from accelerating as much. However, it's curved around here, so the air here is going around the outside. So you've got weight acting down and air resistance acting up. And there is a person falling. In order to increase air resistance, if you're falling, if you happen to be falling by mistake, say you've accidentally on a plane and it's blown up, and you want to increase your chance of survival. It's not particularly high regardless. However, what you can do is make yourself big. So basically, spread your body out so that you're not feet down or head down. Your whole body is spread out. Ideally, if you could be on top of something, just make your surface area bigger. That'd be great. However, just using your body, just spread yourself out. Chances aren't great, but it does increase your chances as much as possible because that air resistance will be bigger, meaning your velocity, final velocity when you hit the floor should be a little bit lower. So friction caused by air resistance affects the speed and fuel consumption of vehicles such as cars, bikes, and aeroplanes. Vehicles are specifically shaped or streamlined to enable air to flow past them as easily as possible, therefore reducing air resistance. And this is very similar to what we talked about earlier with the shark, sorry. Here you can see, in fact, I see if I can draw it on here. And now, let's say they're both driving with a forward force of 1,000 units. Let's say they've both got the same engine in and they've both got the same mass. 1,000 newtons. And I'm drawing this with a mouse, so forgive my poor drawing. 1,000 newtons. In reality, these numbers probably a lot bigger, but I'm just keeping them simple. Here, air hits it, hasn't really got anywhere to go, so it just sort of hits the windscreen and slows it down. So let's say it's 400 newtons. Again, totally making these numbers up. The resultant force equals 600 newtons, 1,000 minus 400. Here, air hits it and it's streamlined, so the air flows over it. Now it's still going to cause some, resistance, but let's say it's 100 newtons instead. Again, making these figures up. So now the resultant is 1,000 minus 100, which is 900 newtons. So in order to travel at the same speed, you have to increase, or to get the same level of acceleration, you have to increase the driving force of the engine, which means using more petrol. So this car here on the right will use a lot more fuel than the one on the left, which is streamlined. Now I'll just clear this. 2 seconds. Don't use this normally in the classroom. I use the whiteboard pen. And again, this is a similar sort of picture. You can see this car's got much greater air resistance than this one here. Let's have a look at some past paper MCQs. We'll start with some sort of key stage 3 ones, and we're going to end with A level. Choose the best definition of friction. So let's go through them. A force that resists movement because of the gaps between surfaces. It's more the rigid surfaces, and that's not the only time you get friction. A force that increases movement because of contact, well, it doesn't increase movement, does the opposite, so it's definitely not that. A force that resists movement because of contact between surfaces. Yes, it is that, but let's just double check D is not better. A force that lubricates movement because of contact between surfaces. No, it's definitely not that. It's the opposite, so it is C. Now, keyword there, lubricate, which we haven't mentioned yet. That just means some sort of something which will reduce friction. So, for example, it's usually a liquid that you can apply, for example, engine oil you put in a car, so that when the car parts are moving, you don't get too much heat and cause a fire in the engine. Which keyword matches this definition? Reducing friction between surfaces when they rub together. And I've just kind of answered that one by mistake there. It's B, it's lubrication. So this is another key stage 3 question. Bukayo carries out an investigation to see how much friction acts between his trainers and the classroom floor. He attaches a newton meter to his shoes and pulls it. The diagram shows the moment that the trainer just starts to move. So the trainer's just starting to move. The value is closest to the force due to friction acting. So what value is closest to the force due to friction acting on Bukayo's trainer? Okay, so you can see here, it's just starting to move and it's taking 7 newtons. So it's going to be about 7 newtons. So it is 7 newtons. Now we're looking at a past paper MCQ question, paper 2 from IGCSE. This is actually the first learning objective. Back to that again. I've missed it off there. A box of mass 2 kilograms is pulled across the floor by a force of 6 newtons. The frictional force acting on the box is 1 newton. What is the acceleration of the box? So we need to work out the resultant force first. So you've got 6 newtons. Actually, this is both first and second learning objective. 6 minus 1, which is 5. And then you do F equals ma, force mass times acceleration. So A is F over m. The resultant force is 5. The mass is 2. 5 divided by 2 is 2.5 meters per second squared. And it's like, say, a past paper IGCSE question. And now this is a past A-level paper question. A wooden block rests on a rough board. The end of the board is then raised until the block slides down the plane of the board at constant velocity v. So constant velocity, straight away, I know there's going to be no resultant force. So friction must equal the weight. Which row describes the forces acting on the block when sliding with a constant velocity? Okay, so the frictional force is always going to be up the plane because it opposes the motion. So it's trying to move this way. So the friction is going to be up. And the resultant force on the block, well, it says constant speed. So that means no acceleration. So force must be 0. So the answer is therefore C. Okay, thank you very much, everyone. I'll soon be posting the next lesson, which is on gravity, or rather gravitational acceleration. Thank you very much, and I'll see you later.